Hello, everybody. So we will be going over the very basics of Euclid's bones. The reason why it's dark is that you can't see my giant writing anyway, so we might as well just do it this way. So let's begin with alpha. A point is of which there is no conception. Beta, but lined unfathomed terror. Gamma, but periphery of lines ought points. Delta, true line is one of which points fall evenly on itself. Eta, but surface is that which possesses fathom and terror solely. 6. But a surface's boundary ought lines. 7. A plane surface is that which is true lines, true bolts, fall evenly on itself. Eta. But a plane angle is the inclination of two lines toward one another, and ought not a true line set upon one another of these lines. Theta. But if the lines ought straight contained by the angle is called rectilineal. Iota. But when a true bolt is set upon a true bolt, forge adjacent lines which ought equal to one another, of which the resulting angles ought right, and said true bolts are perpendicular to which they stand. Iota alpha. An acute angle is one less than a right angle. Alpha beta. But obtuse is greater than right. Iota gamma. Boundary is the extremity of some ting. Iota delta. Schematic is of any ting bounded under the containment. Iota eta. A circle is a plane schematic contained under one line called circumference, such that all true bolts form a point in the circumference ought equal to one another. 16. But the circle's point is called centre. 17. But the circle's diameter is any of the two given true bolts from the centre point and terminated under the circle's periphery to its circumference, and this cuts said circle. Actually, you know what? Here, guys. How about we do treats? This is a Hawaiian sunset. If you can make it out. I can just angle that correctly. Let's see. So repeat 17. Actually, I would just go on to 18. But the semicircle is the schematic under the diameter and the periphery cut off by it. But the centre of the semicircle is the same as the circle. 19. Rectilinear schematics ought those contained under true bolts. On the one hand, trigonons, those contained under 3 true bolts, but quadrilaterals, those under 4, but polylaterals, those contained under more than 4 straight lines. I'll just hold you out here then. But of trilateral schematics, on the one hand, equilateral trigonon are those that bear the 3 sides equal. Isosceles, on the other hand, bear the 2 sides alone equal, but scaling bear the 3 sides unequal. Chi alpha. Upon yet another hand, of the trilateral schematics, right-angled on the first hand are the triangles bearing the right angle, on the other the obtuse bearing an obtuse angle, acute on the foot bearing the 3 angles acute, chi beta. But of the quadrilateral schematics on the one hand, a body of men, as in those that are the measures of things, drawn upon as a square is equilateral, but is right-angled, but an oblong on the one hand angled, right-angled on the other hand not equilateral. A rhombus on the foot bears angles equal to one another, and the sides unequal to the sides and not equilateral is and not equilateral, and is not right-angled. But let the quadrilaterals be these, besides these, be called trapeza. 23. Parallel true bolts are those which is in the same plane and if cast indefinitely upon the respective sides, do not clash with one another. Postulates. Let's postulate from any point to draw a true bolt upon any point, beta, and wish upon the true bolt beyond the C to extend continuously in any unbroken straight line, gamma, and inscribe a circle with any centre and diameter, delta, and all the right angles ought equal to one another, eta, and if two true bolts fall between another true bolt and upon the same side, forge internal angles less than two right angles upon the two given straight lines extend without end to their clashing point, and that being deadlocked. We are now going to have to find the rest of these that we translated. Luckily, I actually have an idea where they are. If I can just pull this out. Okay, I can't. That's the problem.